Hey, what's up, folks? Welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit. Join me every week. My brother Pedro. Hello.
Good morning, everybody. I'm Pedro's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is the show where we combine DIY electronics and inspirational projects to make inspirational projects. Wow, I butchered that intro.
That sounded
Oh
right.
well. No,
Sounded
it was
right.
It was so raw. It's fine. Hello, everybody hanging out in the Discord chat room. We are hanging out there. Welcome to the show. It is episode 481. It is Wednesday, May 7th, 2025. If you'd like to join us in the Discord server, you can do so by going to Adafruit Discord. Discord.gg/Adafruit is the URL for that. We have it in the top purple banner there, so folks can join in. We'll give a couple moments for folks to join in before we shout them out. But yeah, I'll circle back to Discord. Let's get some of the coupon code and freebies out of the way as a part of the beginning of the show. Adafruit.com/free, where you can get all the details for all the freebies that you get if you spend certain amounts of money, starting off with orders of $99 or more. You're going to get a PCB coaster with a golden Adafruit logo. If your order is $149 or more, you'll get the PCB Coaster Plus, a KB2040. It's a lovely RP2040 microcontroller. And at the top tier at $199 or more, you'll get the KB2040, the PCB Coaster, and free UPS ground shipping for continental US only. All of these items get automatically added to your cart, which is great. And on top of that, for folks that are watching the show live, they get a 10% off discount code. Type in the code in your checkout code box. Mailbox is this today's coupon code. Good for the next 24 hours. It expires midnight tonight on the Eastern Coast. So yeah, Mailbox. And you'll get some freebies too if you spend those tiers. Thank you, everybody, for your orders. We really appreciate keeping this thing going. All right. Giving shout outs to folks that are watching and chatting. We are also on Facebook, LinkedIn, YouTube, Twitch, and X. So if folks want to say hi there, we can bring folks in. I'll start off with folks in Discord. I want to give a shout out to Duester and Squid.jpg. Hello, sirs. And who's on YouTube?
Shout outs to Omri.
Omri, hello, welcome to the show. Thanks for watching us live. Cool. All right, let me see if I can. Whoop, whoop. All right, so last week we talked. We gave a nice demo of our upcoming project, the Motorized Camera Slider V4, 5.
I lost count. We were looking at the past ones. We've made
yeah. I am in the midst. I am like shoulders deep in the water of documenting the Learn Guide. It is a very big project. It is a very personal project because it's just something that we want for ourselves. Mainly, I want this motorized camera slider. But what we can do is look at some of the work in progress in the Learn Guide in the back end of our admin Learn Guide and just kind of walk through it a bit. We originally started this project back in 2014, which is probably 11 years now. And we've gone through different versions of it. This latest version, of course, uses the Trinamic silent stepper drivers, which is like the way to go now with like super smooth and super silent motor control, stepper motor control. So that's kind of why we wanted to bring this up. And the stepper motors are fairly new. I feel they came out this year, maybe the end of last year, which is fairly new. And this one uses, 2 motors this time, which is really cool because now you can do linear motion left and right and panning left and right. And the software was a whole thing that includes a lot of math and a lot of gear ratio stuff that we had to figure out. Shout out to Liz Clark for doing all of that. But let's go ahead and take a look at some of the parts and some of the different steps that we got going on. So let me load this up. Where's my web? There it is. All right. So a couple parts. The main dev board for this is the KB2040 RP2040 dev board. That's going to allow us to take in some big voltages for powering the motors, along with these 5-volt buck converter. We needed a display so that we can just show some user interface stuff. So controlling with a rotary encoder. So that's why we have a rotary encoder. And we are able to make it portable by using this 8X AA battery holder, which has a DC barrel jack. So that is what's going to power the thing. And then, of course, you're going to need 2 stepper drivers. The TMC2209 is what we're using, which is really silent, and it has UART control, so you can do 2 motors at the same time doing 2 different things. There's kind of a couple of bits and bobs, like some PH connector or some JST XH connectors for quickly connecting the end stops, because we're using I'm not sure what they're called. I guess just end stop switches. And we have these quick connect cables that have these JST connectors. So we're trying to make everything plug and play with our custom PCB, which we'll talk about a little bit after I go through the parts. So just a bunch of parts that populate the PCB and make the wiring a lot easier. When you start wiring up 2 stepper motors, you just get really rat's nesty. So we had to make a carrier board that will hold the 2 stepper drivers, the DC barrel jack, the 5-volt buck converter, the display, the rotary encoder. I'm running out of fingers for all these components, so that's why we needed to make a PCB. We've gone through 3 iterations of the PCB, which is fine. You know, that's typically the number of iterations you go through, especially for something with this many connections. So we have all those listed out, and then some extra bits and bobs. Back in the day, you know, it used to be a little bit difficult to get certain parts like timing pulleys, wheels, G2 timing belts, that sort of stuff. But nowadays, you just can't compete with places like Amazon where you can just get them next day. So we don't actually stock some of the things that we used to stock for building CNC stuff. So most of these bits, like the pulleys, the timing belts, the tripod screws, all that stuff is actually linked to Amazon. So I had to hunt those things down. And also the stepper motors. Like, we don't stock short body stepper motors, but you can get them on Amazon and other places. But yeah, so a lot of parts for this. And I still am in the midst of getting all the screws and stuff like that as well listed here. So that's a whole other thing that I'm in the midst.
I noticed even on Amazon, a lot of the screw sizes, the links for them have been updated and changed. So in our guides where we list parts for those, it's going to take you to a not found page now. I noticed.
Yeah. So it's kind of hard. I tend to not link screws anymore, because it's just like, here's the screw size and here's the length of screws, as opposed to here's like a place from Albany County or Amazon, because these places can switch around. But as long as you have a list of what screws you need, I think it's okay. So that's a little talk about the parts. Yeah, a lot of parts. Now, when it comes to the circuit diagram, this is where we have a link to the PCB file. So it was created in EagleCAD, but you'll have access. You can take that EagleCAD, bring it into KiCad, or bring it into something else. And we also have, I think, the Gerber file, so you can upload it to places like PCBWay or JLC PCB, or the Eagle file is native support in OshPark, so if you want to get that manufactured. Yeah, but it is an open file, so folks can download that. Here's just a screenshot of the backside or the front side of the PCB. And then here's the actual fitching diagram. If you are so daring enough to make all of these wired connections, you can see kind of why it's a little rat nesty. A lot of wired components going on here. You know, you got like 8 connections just for the TFT display, because it's using iSpy connections. So you got like 8 connections there. Again, we're using the KB2040 because it has the ability to do a raw power input, which allows us to use the 5-volt buck converter, which takes 12 volts. So we're using the DC barrel jack to give us 12 volts, 1 amp, to power the 12-volt rated 2 stepper motors, but then the buck converter brings that down to 5 volts so that we can power the KB2040 and the display and the rotary encoder and the 2 end-stop switches. So you're looking at a lot of wires if you're not doing a PCB. And I originally was not going to do a PCB, but just after iterating so much, it was just like, we got to make a PCB. So that's why we have that here. And it really makes the mounting so much easier, because like we're using socket headers, so we can just pop things in, and then you don't have to wire up, you know, the switches, because we have like these JST connectors that we can use the quick connect, so we can just literally plug them in, and there's not that much soldering, because you just got to solder up the headers, and then you just pop everything in. And then there's screw block terminals for the stepper motor driver, so that makes it a lot easier as well. So really good way to go. But we still have it all broken down here for all the wired connections and stuff in text format. So that's the circuit diagram. We are using CircuitPython, of course. So of course you have the documentation on how to install the latest version of CircuitPython onto your KB2040. Pretty boilerplate. The code page, again, huge shout out to Liz Clark for coming up with the code, and then making the code page is breaking down how all the things are working. We're using quite a few different things going on here. So the keypad library, the TFT libraries and coders, handling the graphics, handling the UART. We actually don't have a project yet that uses the UART mode with the silent stepper drivers, but this shows you how to set it up. And then it walks you through all the menu item stuff, how we move the motor, how you want to customize the motor, if you want to change the timing or the velocity, how the loop is working, using the keypad events. Nice big chunk of code. Good stuff. So after that, we walk into the PCB assembly. So I have broken down here all the various headers that you'll need and components, like the DC barrel jack, the terminal blocks, the JST connectors, the rotary encoder, etc. Also some resistors. You actually need some resistors in order for the UART stuff to work. So that's just a quirk of the UART mode with the stepper drivers. But they're all labeled here. Liz actually designed the PCB in Eagle. She did a great job on routing it and adding really nice graphics to the silk screen. Of course, there's pins and little helpers here to let you know where things are, like the voltage and ground for the screw block terminals that you need. Oops, cancel that. So this just walked you through soldering all the different bits. It is a double-sided board, so you need to add. So one side has the stepper drivers, the microcontroller, the components, the resistors, and the other side has the TFT display and the rotary encoder. So this just walks you through installing all the components. They're all through-hole components, so it's easy to assemble, which is nice. And then here is the top side with the rotary encoder and the header for the display. You do need to create some wires, because it's a little bit weird to power the stepper motors. So we're using these wires to kind of route the DC barrel jack stuff to the screw block terminals of the stepper driver. So you can see that here in this photo. When you start installing the boards, you can see how the power cables are actually, this is the only way to connect to the screw block terminals with these external wires. But that's fine. You know, it works out well. And then here's the last bit here where you're plugging in the display. And yeah, that is the PCB. It's its own page. So after that, I try to create sub-assemblies for this thing, starting off with the pan motor. You have the big ball bearing, the 3D printed gear, the stepper motor, and an assortment of screws, along with the 2 3D printed parts, the camera plate, and the pan mount. So those 2 things are what we work on here. Just setting everything up, installing the tripod screws. And really, when I took this apart, took it apart, put it back together, you start learning about order of operations, and you start you know, figuring out this is the right order to do things. So this, because the assembly is so big, it really was important to kind of just break it apart, submodule it and then just be like, okay, this is the right order. So that's what this works on. By the end of it, you have your stepper motor pan assembly, which is what we're calling it. After that, we work on the carriage assembly. The carriage is the main thing that's sliding along those two pieces of extrusion. So we start off with the end stop switches here. So just getting those assembled onto these mounting plates. The next thing is you kind of sandwich these pieces together. Like where you're reusing mounting holes, you want to kind of layer things together. So we're starting off with the 8 AA battery holder, putting that down, and then you're putting the lower carriage part on, and then you're putting the mounting plates for the end stop switches. So those all get sandwiched together, which is interesting because instead of creating all of these mounting holes, you can just reuse your mounting holes and just have these 3 parts. So that's literally 3 different 3D printed parts that are sandwiched together. So I have that all labeled here and broken out. But by the end of that, you can attach the second stepper motor. This is the linear rail stepper motor. And then you got your timing pulley here, which is not 3D printed. It is aluminum. It's a 36 tooth timing pulley. So you get that in there, and it comes with set screws, so you can attach it secure it to the shaft of the motor. Here we got our batteries for the AA battery holder. This is a pretty chunky battery pack, but with 8 AA's, you're able to get 12 volts, 1 amp. So that's what we need to power this whole thing. So it is portable. I mean, that's really cool. Once you get your batteries in there, we attach it to the clips. That's the way it just kind of snap fits under these clips here on the bottom of the carriage. And then we're working on the carriage gear. So this is a 3D printed gear. So we're just attaching that together. We got these pulley wheels. That is what's going to slide or roll along the profile of the extrusion. So we get those installed with some M5 by 25 millimeter long screws. These are really long screws because you have to kind of go through the top of the carriage, through the pulley wheel, to the bottom of the carriage. But we did some clever things where we have some hexagonal captive cavities that will keep the nut, the hex nut, like in place. So that works out really well. No need for set screw or for heat sets or anything like that. You just kind of pop it in, flip it over, and then just tighten them. So once you got that, we have a dedicated mounting plate for the PCB. So that gets installed with some more screws. And then this right here is where you install the panning assembly to the carriage assembly. And I just like how you just snap those together because it's using a ball bearing. So you just have a friction fit for these two assemblies. And then you got kind of your whole assembly there. So after that, then we can run into the last part. The last thing is to put together the aluminum extrusion. So we have these two left and right feet, we want to call them, like foot mounts. They're mirrored, so you need to know which one's left and which one's right. So I have a photo here to let folks know which is the left and the right. And I might go as far as adding some labels.
Inside Bamboo Studio.
I want to do I'm going to probably do that in Bamboo Studio, and then just save it out as a 3MF, right? So that folks can change that up if they want. But for these aluminum extrusions, you tend to use M4 slim T-nuts. That way you can like slide them or pop them into the rail in the profile of the aluminum extrusion. So you just want to line those up and start tightening things up. And then once you have one foot, you can start sliding in the carriage assembly through the railing, just making sure that you're not pinching any of the wires. There's plenty of clearance for the wires and cables to fit underneath or through the two aluminum extrusions. And then you can install the right foot, and then you just kind of have to move the carriage so that the roller wheels are fitted into the profile. So that's kind of what we're doing here. A little bit hard to show that, but you can, I write it down that you have to kind of, fit those wheels into those profiles. So that's nice. After that, we I got a lot of writing to do. So this is where I'm like in the middle of getting the timing belt installed along with these print in place end caps that will actually add tension and lock the timing belt, which I think is really clever because it's it used to be like 3 different pieces, but now it's like a print in place with a built-in like lever that will lock the timing belt in place. So we just walked through installing that, and then can't quite get the image here, but you're basically you're making the belt fit over the timing pulley on that stepper motor, and then you kind of add tension on the other side and then lock it in place with this ingenious built-in lever on the end cap there. And that's kind of it for the assembly. Then after that we can start plugging in some things like the end stop switches and wiring up the stepper motors to the screw block terminals. We do want to add some additional standoffs for the PCB to be elevated. And the last parts here is just kind of plugging in the battery and then, putting in this crank, this 3D printed print in place crank that has hinges on it and has like a little rotating paddle thing so that you can easily crank the position of the panning motor. So yeah, still a bit of work to do. Like I said, I'm shoulder deep into the documentation. I just wanted to give folks a little preview of what we got going on. It's a big project. I have it listed as an advanced project because it does require a little bit of experience, I think, to assemble this thing. Again, it's meant for our own internal uses, but why not make it into a project that folks can build too? It's going to also be a good jump off point if folks want to remix it or just take some certain pieces out of it to build their own crazy camera rig. Yeah, so that's kind of it. Coming next week, hopefully. I think next week we'll be in a good spot to button it up and finish the rest of the tech stuff. Let's see what else. Okay, so I have been able to use it. So I wanted to show some folks just a couple of shots. First up, we'll start off with our cat here. This is Harriet, and this is just showing a little bit of the motion that the camera rig can do. I think this is like the fast setting. So it's just like a 8-second long clip, but you're getting that slide and you're panning and you're focusing on your subject and it's staying in the center of the frame, which is really hard to do manually. Like you can do it, but it would take me several attempts to get that smooth of a shot. We also, of course, can do just a standard one mode. We try to do a lot. This was shot with my iPhone. I think it's still a little shaky because like I'm on carpet, so maybe I can add some maybe sandbags or something to stabilize the C-stand that I have it propped up on. But with the cat, you can see it was really smooth because it's just on the floor. It's not on any C-stands. And I could probably get a second tripod to really get it nice and straight. So it really depends on what your thing is on. And then the last demo shot, this was a really hard one to get. Let me play it again here. This is on our patio. I have my MIDI controller out here. I'm just doing a little bit of a finger drum jam. So this is again panning, sliding and panning, and trying to keep the the MIDI controller in the center of the frame. And then I have this kind of beautiful bokeh stuff of our cafe patio lights and Christmas lights on the back of our patio. This is, I think, a 20-second clip. This is using the one-shot mode. And of course, you can customize the timing and all that in the code, in the CircuitPython code. So those are some demo shots. I really want to take it out to our local park. It is springtime here in our part of the world, and there's lots of foliage and flowers, and we have like some nice statues at this park, and I just want to get some really nice cinematic shots to kind of show what you can do with this.
Very cool.
Yeah, thank you. But yeah, getting it outside and getting some, some outdoor shots is something that would be nice. Not just for like, these lockdown, product shots. I also want to get some nature in here.
Mm-hmm.
So that is
some time lapses, yeah.
Yeah, so time lapses is something too that I want to get. We do have a time lapse mode. And I think we have like 1 minute, 5 minutes, 10, 30, 1 hour. You can make as many as you want in the code. But yeah, the code handles
definitely a good one to show off.
Yeah, especially with
if it's something you can't do, even with really good stabilization, sure you could, just walk around it in a good like in-body stabilization on a camera would be good, but you can't redo that no matter how good the stabilization is with a time lapse. There's no way you can stand there for 30 minutes or whatever and do that. So I think that's a really good way to show that off.
Yeah, for sure. Yeah, lots of fun. More demos and stuff as we get closer to the release of the project and actually using it. Right.
Super cool.
Cool. I want to give a shout out to Kevin McClear. Hello, thank you for joining us. Oh yeah, he wants to build one. Very cool. And a shout out to Nikita as well on YouTube about a circular path, the 3D model that we used. Yeah, that could be a cool one. Yeah, I also want to try to get a time lapse of our Bamboo printer printing something.
Oh yeah,
maybe that's a meta thing. It's printing itself, right? It's like printing another bracket, and it's like focusing on the print, and we'll do a time lapse of this thing just growing. That'd be really cool. Yeah, that's a great one as well.
Even if it's just pulling back, that'd be super cool.
Yeah. Also from Kevin saying, great demo. Love the range of travel. It really keeps it in the middle as it turns. Yeah, that was like was fun. You have about 600 millimeters of travel, which I think is plenty to really capture some motion. And if you got a subject that's even more close up, it looks like you're really like capturing a lot of space. So that's cool. All right, we're doing good on time. Just about 30 minutes into the show, and
all right,
we think we discussed a lot. All right, so I think we'll just run into our next segment, rapid render.
I think so. Yeah.
Okay.
A little bit of a prototype slash on your end, what we just did.
Yeah. This is a little bit of prototyping and a little bit of this week's project.
All right, let's go ahead and check it out.
All right, let me bring up the banner here. Hello, everybody. Welcome back to Rapid Render. This week, we're taking a look at a new AI tool.
All right, this week we're going to take a look at Backflip AI. If I go into the segment here, this one is looks like one of their focuses is like 3D scanning to CAD, and this one was not free. I did have to get an account, put my card in for the free trial, and let's take a look at the interface for this, which is a little impressive. We take a look at some of their demo stuff that they have here. Here's some of the images they were able to generate, and it looks like it's geared towards gaming. Some of the meshes look pretty good, like in terms of the polygon generation for it. You can see that you do have a little bit of what we call, like, when you scan something, it looks a little bit mushy. It's not like completely straight, but they did a pretty good job in trying to make the polygons nice and uniform. So they have a nice little interface when you actually go inside of it. You have some good editing tools. So right off the bat, you can like delete any of the floating geometries that are generated either through the text to AI generation or the scanning. So you do have those clean up tools. You have like symmetry tools. You have like texture like cleaning up. And the export options, you do have a couple of the different formats, and you can target different poly counts for it. And here's what some of those tools, interaction of those look like. So you can have your canvas and you can like sort of mesh different items together. So this is me just exploring how some of the operations for that work. And I think was like, oh, let's make like a plant with a gun. What does that look like? Just to see what the
Oh my.
interactivity of it. So you can use this canvas to create your models in terms of, you know, grouping things together.
Yeah,
So
great for kit bashing. Yeah.
exactly. Yeah. So I didn't try like the text to generate, but I just quickly was checking out like the sketch tool, and we've seen some other sites do that. And right off the bat, just that scribble, it was able to generate a
Pokemon.
Yeah,
two-headed stork,
like a two-headed ibis or something. So that was super cool. I was like, oh, okay. I wasn't even trying to draw that. So what happens when you actually try to draw like a human? And I think I tried to do that here. So draw a little guy, and didn't do a really good job of it. So when you don't try, it gives you something good, but when you're actually trying, it gives you like a squiggle. So yeah, disappointing in that one.
Oh, it's like real time, like as you each brush stroke is like trying to create something. What is that?
So that's pretty impressive that it's able to
maybe if you gave it a prompt as well. It's like, I'm trying to draw a human head.
You know
with
what?
spiky hair, 2 eyes, you know, ears.
It looks like it's trying to draw like a little devil guy or something, but yeah, super cool that it is able to generate right after you lift the stroke for that. Oh, did I go too far?
Yeah, don't go too far.
Oh yeah.
Right. How do we get to the dog? Okay, so you're gonna upload an image.
Yeah, so that's the main thing that I was focusing on. Last week we were trying to generate our dog Rufio here. Since 2 weeks before, you were generating the mom's cat.
Mm-hmm.
And there was some hilarious generations for that. So we're just going to continue this trend in trying to see how ridiculous these AI generations can try to make animals.
Look at
I don't think a lot of them are targeted towards that. Mm-hmm. And here's what some of the variations of Rufio being generated. And yeah, I don't know why it's making these so creepy in terms of giving it like a skeletal structure that's on the outside of the body.
It's quite weird.
Yeah, this one's pretty creepy with the
demon dog,
the ribs. Yeah. So I do click inside these to try to get more of a.
Oh no! Why would you show this? This is a.
So I was like, okay, it can't generate it if it's more geared towards like a quadruped. A lot of the AI generation, like image to video generations that I keep seeing on like the TikTok feed, are of the dogs that jump, start dancing out of nowhere. They turn into like a human. So I was like, what if I just grab a screenshot from this to see if I can get Rufio just standing up?
Yes, I agree. On Twitch, Toby is saying that this is terrifying. Yeah, we should have gave a warning that you're about to do something quite
terrifying. A lot of these are people that post these is because of how ridiculous it makes them. So some of them will like completely turn it into like a human where it like completely looks like a humanoid, where the dog features completely go away and it turns into like a dude with like human teeth and all that.
The way the ears flap and the hair bounces. Play that again.
That's pretty realistic.
Very impressive. Like
right?
Transition from
and it's just image. A photo. So this was on TikTok. I forget what the
whoa. His hand.
The filter name of it is, but everybody's been posting this one. Yeah, for this one, it looks pretty good. Then there's some other ones that are more subtle where it looks like it's just, sort of scooting about. Yeah, I wanted to see if it would generate this, if it's more of a quadruped that it's geared towards. I want to see if it could generate this. So here's some of the variations for the generation of it, and it is just as creepy as what the video portion of that looks like.
Yeah, this is a creature from Poppy Playtime now.
So this is what these segments are going to turn into. How ridiculous can AI generate something? And just making fun of it.
Oh my gosh.
Buttocks is there.
Yeah, the shoulders and
it looks like a human in a costume.
But you can't see the subtle changes in each version. Like you have more of a mouth and more pronounced shoulders or whatever. This is more of a better photo, maybe.
That's what I was trying to do. And in later on, you could see that you can try to refine it more based on different photos, and this is what it was able to come up with. Still not as good, although the top right looks a little bit better than the rest, but I don't know why it's giving it like this weird crocodile skin. It looks like
the hole in his
it
is wild.
yeah. And I'll show that close up.
It's wild.
But yeah, the whole.
You know, if you can give it multiple images of different angles of
that's what I was. Yeah, that's what I show here next.
Oh,
yeah,
okay, excellent. Let's
I don't
roll.
know why I gave it like a.
It's
a pencil holder.
Yes. Yeah,
That's what I should have printed, huh?
Mm.
But yeah, the top right one looks like the best one here. It looks like he has like a superhero suit on or something.
Yeah,
did okay with the ears, how fluffy his ears and tails are. It's always difficult to try to generate, so I understand that.
Something like you can see the skeleton of his head.
I know, that's what it kept showing up with the variation.
Underworld dog.
So this is me just trying to, again, figure out what the UI for this is, and bringing it into the canvas to see if I can sort of mess with the mesh here. And yeah, you can see here the crocodile skin looks kind of creepy. I know it's trying to do like the way his haircut probably is what made it generate that. Looks like he has like clothes on or something. And I think you can try to refine it here with an additional photo. This is what I'm trying to look at here. Let me speed it up.
So you have fine control over the polygon count, which is nice.
Yes. So here I am trying to tell it to, hey, base it more off of this photo. So here's it. I grabbed another photo. I'm like, hey, try to make it look like this instead. And let's see. And here it's what it looked like when it's trying to refine it.
Yeah.
Yeah, this is pretty good in terms of the
nice looking
tools and your canvas and palette and how you're able to kit bash the different geometries together.
And this is all in the web browser, yeah?
Yeah, this is all the web browser. Thought I had cut this up a little bit. Here is.
How long do you think you waited? Like a minute or 2 minutes?
I think like 5 minutes. So not the best. So it's trying to. Looks like it tried to smooth it out.
Yeah, his like face structure is like all kind of deformed.
Yeah, it's trying to match what that last photo was. So not the best. And you can see here his little paws got a little messed up.
Yeah.
I went with the original one that it first generated, brought it into Blender just to see what the what that object looks like with the mesh count of.
It's a watertight mesh. Yeah, there's no broken normals or.
Yep, that all looked good. So brought it into Bamboo and just printed it off from there. And if we go over to my desk, here's what that print looks like. So I just added supports inside of Bamboo, and here's what that print looks like.
All right. It is dog shaped.
Yeah. It does have that crocodile texture.
Or like a pickle, kind of like this prickly pickle texture. And
give him like a big old fupa there.
That's wild.
And it looks like he has like a collared shirt on or something right here.
Yeah.
But it got his little snoot the way it is. And I should have added it, like painted different colors on him, but I think this took like 2 hours and I was out of time. I needed a thumbnail.
Yeah.
But yeah,
that's pretty impressive. Yeah, I wonder if you were to take a photo, like 3 different angles, a profile, a front view, maybe an angled view, and then all in the same, shot or background. Maybe the tool is able to decipher between the 3 different angles. It can tell what the object is versus what's the background.
I have not seen any of these have that interface where it asks for multiple image sides of it. So I would totally would have done that. You usually see that in scanning apps and programs.
Yeah, Polycam, I think is what it's called, is where you would just take
like 50 shots of it.
Shots of just over and over again, and then go back, and then the top.
That would definitely help generate a better image, but none of these have to date that I've seen, and it should be right where, when I'm always exploring for the upload image, There's
Yeah,
everything
this
has.
looks like a dog. It is a dog.
Yeah, it looks like he has clothes on.
The closer you look at it, the more like, what is this dog? Like, it's weird things. But I think from like the back, which is impressive because the photo does not have the back of the dog, but that looks
right.
like the most dog, which is wild. And the tail is pretty good. I mean, it's a bit of a crocodile tail, but or maybe it's like a foxtail. I don't know. And did you flatten out the bottom, or did you just lower the model in the
I
slide?
did lower the model. It did. This part was flattened. It was his front legs that were in the air a little bit, and his tail. So that's the only reason I lowered it. It was only like by a millimeter. So pretty good job. This is like 100 millimeters tall, and it took about 2 hours to print this. I think it's like a 6% infill, so not a terribly heavy print. We are using the Protopasta glitter gold filament.
Yeah.
I tried using the wood filament just because it matched what his fur color is a little bit better, but it came out like garbage. The wood filament is still stringy. I tried the bamboo profile for it, but it's not actually bamboo wood PLA. It's like the Hatchbox one, so I have to try some of their filament.
Yeah, I haven't used wood filament in quite a few years now, but yeah, I always remember it was a little bit difficult to print with.
We'll have to do tests with that. I keep seeing the what was it, the TPU one from Bamboo. They printed the what was it, the Swifty boots from Minecraft, so the kids want that printed out. We'll have to try that for the TPU stuff. But yeah, in terms of I have to cancel my subscription to it, make sure I don't get charged.
I see. So account creation is a bit of a sign up. You can't use your Google account, or
no, you had to put a credit card in. So that's the only downside to this. Most of these let you they're free trials. Don't have don't force you to add any payment information. But I get it. The way that their tools are set up and the way that you're able to in the canvas that they give you to sort of kit bash different things together. And again, I don't think it's geared towards like animals, although they did have those impressive looking trees and plants in there. That good when you look at the polygon for that count for that, and the way that it's structured, it looks really clean.
Yeah, so it's almost like you're gaining access to these already made models. So maybe you're developing a game or some sort of indie movie, and you just need like an assortment of trees and animals and buildings and whatever. I saw they had a bunch of space guns and weapons, so those would help you kind of get your idea started. So that's kind of what you're doing. It's kind of like having I don't know, is Turbo Squid still a thing? I remember that was like kind of like the Thingiverse of 3D models for visual effects folks.
This would definitely be cheaper than any of those, because I'm pretty sure for it, I think it's $20 is the cheapest payment. Like I forget what it entails for the $20 a month. You get like, forget how many, like 10 model generations, but whatever the cost is for that, if you're getting all these assets that you're able to grab within that month, it's going to be a lot cheaper than paying per model at Turbo Squid or any of those iStock, whoever has models to get that comes with a license,
Yeah. So let's go back to.
Yeah, it tells you in there. Actually, no, I think I cut that out because I had my card info in there.
Trying to add. There it is. Our screen got a little confused, but so their website is Backflip AI. They seem to have two different modes, like a parametric 3D scan to CAD stuff, which sounds interesting, and then the idea to mesh is what you were working with, the mesh stuff. Very different when you go from.
I will have to try that. I didn't realize.
Yeah. That's cool. So you give it.
I'll have to try that next week.
Just maybe a step file. A step file, and then it'll turn that step file into a parametric. Maybe you can stretch it out and stuff. That's interesting, because then it gives you a wow. We'll have to try that for next week. Like doing some mechanical step file, and then can I make it parametric? And that would be cool. Yep. All right. So check out
look at their client list too, like Bosch, Audi. So Dr. Gillette, GM, Honda.
Wow.
The origin.
Mark Forged. Is that their engine or something? Not sure. But that's their website. Just some caveats there, as we talked about. But that's this week's AI tool that we looked at. And that's this week's Rapid Render. All right.
Everybody freaked out by the...
Yeah, I think that was the point. It's like, how can we shock people with these terrifying AI-generated models? That's the whole point of the segment right now.
So it's the dancing dog one I keep seeing, and then one where it's just like a make dance filter.
Yeah.
Where the people holding a dog, and then they take a bite out of the dog, and it turns like into food.
Oh, I think I've seen that on my Instagram feed.
That one? Or the lady holding the baby, and they throw the baby and they start dancing.
Oh my gosh! Throw the baby and start dancing.
It's just an image. It's not real. Can you model this? What is it? I can't tell. Is that
it looks like a skull or a fish. Interesting.
Nikita says yes. Itchy fidget toy. Oh, because of his back.
It's cake.
Yes, it's a scrub.
It's a loofah. I thought it was like a puffer fish, but with like denture.
Oh, that's a cake.
Oh
yeah, it has a face on it.
How'd you get that in there? I guess Twitch allows you to have custom emojis or something.
Yeah. Well, is it like the how Siri can on iOS can generate those custom emojis?
Yeah.
Taith is saying other way step files can usually be reverse engineered to parametric history. Think their tool suggestion, upload images or anything to get parametric step files exported. Yes, we'll test it out. They will have my card info for 1 more week.
That's funny. Yeah. It's like a subscription streaming service where it's like, give us your credit card and you have 30 days free until we charge you. So you got 30 days to watch to binge your favorite TV show, streaming show. Cool. All right. Good stuff. We will slice that out as an independent video and folks can watch that. Maybe you'll see it tonight on Ask Engineer.
All right. Moving on. Take a look at the community makes this week. Timelapse Tuesday. We got a suggestion from PT. I'm guessing it's because of the Mother's Day. Was this mailbox for children? And I tried looking for one close enough to the suggestion that he found online. And this one was close enough to what he was looking for. These are 2 different models that I smashed together, and later on in the not layer by layer shop talk segment, we'll talk about how to combine these. But this is a little mailbox that the kids can insert envelopes and letters, and it has this really cool or I added this flag because of course kids freaking love envelopes and mail and writing things and receiving things, and then the added interactivity of having a lockbox attached to it, a little hinge that goes down, good optimization with the honeycomb shape in the back to cut down on the material. This is super cool. You have a choice of different lock mechanisms too. You have like a triangle, a pentagon, a square one, so kids can pick the different types of keys to unlock this. And this is both the kids wanted one. They both have one by their doors now, so they can send and receive messages and envelopes and all that. This is
a really cute idea. Yeah,
this is
given the kids their own like mail time. Like I grew up on Blue's Clues, and I remember mail time was such a big fun thing to experience. And now you can kind of make your own mailbox for whatever occasion. Maybe you have multiple kids and they can mail each other things, or your parents, I don't know.
This is great. Cool. Yeah. In terms of the design for this, let me jump over to my camera here. See that the way uses 2 M3, I think 30mm screws Then the locking mechanism is super cool. The way that it inserts, you have your different key shapes. Kid can pick whatever shape they want.
Oh, that's cute.
I hope Luna likes the triangle.
Right, yeah.
I remember she likes yellow, so I made a gold one. And then, yeah, it's just a little flap that turns with the key. And then there's like a little mechanism back here, little cutout. You can kind of see it right there that it latches onto. That's how it's locking. And then the flag portion is a different model that I grabbed from a different, it was on Thingiverse, I believe. I had the link on there. And then the way that it goes up and down, it's a little pin with a, I forget the name of it, little thing that inserts, and then this grabs on. So everything is disassembleable or modular. So you can have that. Super cool way to have the kids have letters and whatnot.
Yeah. You could definitely add electronics to this, maybe a servo for the flag, or maybe an IoT kind of thing where you have something that maybe a brake beam or something lets you know that when you get mail, you get an email or something. That could be cool too. Yeah. So I have here. Is it all right if I show the design on printables?
Yes, this is from printables.
Okay, let's see. Where's my web? There it is. So I'm sure you can find other ones, but this is the one we found from BamBam Design. They have a multicolor design here, I think, where it just says post and it has like an envelope kind of icon and just different colors for everything. You got your key, and there's some nice photos of it in different colors. Mailbox for children. There's also a YouTube short about it. It's a mailbox for kids. And there's some text here on the assembly. And I think we got one make.
Customizable. Yeah, I was going to add like a name on there, but they can have fun doing the crafting for that.
Yeah, so clever locking mechanism that's like simple for these type of projects. Pretty cool. So again, from BamBam Designs, it's a free download. So folks can download that. There's all the STLs there. Cool.
Yeah, all the different ones that you can pick for the lock, the shape. So it's based on whatever your kid wants. So you can print that out. And yeah, it's a nice canvas to do some crafting on to make it completely personalized to what your kid likes.
Sweet. All
so
right.
On the subject of making this customizable, they do have on there for the licenses like no remixing, no sharing.
Yes.
I can't share the remix.
Yeah, no sharing.
So what I can do is share how it was made.
Sure.
In terms of adding the holes for the flag part inside of Bamboo Studio, you have this option. You click on an object to load a negative part, and that's what we're actually using to cut away to create the hole. So I'm just loading the actual pin, since that is what's going to get pushed through, and adds you to load that. I think the only thing missing in here, I didn't really look, is a way to align it to the center of two faces. And so I'm just eyeballing this, unfortunately, to what the center of these two
that's good enough.
things would be. Yeah, just making sure that the pin isn't colliding with any of the other geometry in there. And then you can test it out by just slicing it up and seeing how that hole lines up. So just keep in mind to have it aligned to see. I think I rotate on the inside to make sure that what you're aligning, there's like a little the way that little floor or step is. So you're really aligning it to the inside of that, not the outside.
Yeah.
So you can make sure that it is in the center of that, and make sure that the pins are not colliding. Now you can see there the arrow where I'm pointing to. And the tolerances for that, I did have to cut away just a little bit, not enough to I would know what the percentage to like scale that up would be.
Oh, I see.
Just
like 0.1 or something,
maybe 0.15. I would say, to enlarge it. But then again, I was just testing to see. But now we know. I probably would not scale it up just in fear that it would be too big, and it would go through. But you can test that out. Maybe 0.1 in all sizes for the scaling.
Wow. Yeah, it's impressive how much work you can do now. It's just in the Bamboo Studio slicing software. You don't have to like go to Tinkercad, do these minor edits, or bring it into Blender, bring it into Fusion, and you can just do it all in the slicer now.
Yeah,
For quick things like this, like it's kind of really powerful.
Bro, it is so good. The kids are starting 3D printing classes at one of the colleges, and we saw at Best Buy they have bamboo printers, so I picked one up for them. So the kids could have their own printer. That I installed like the handy tool on their iPad, so now they can go in there and do all their printing on their own instead of trying to hog one up. Or we have like 8 of the Creality ones, but I can't trust the kids to print on a Creality. There's open bed, hot. You try to load filament, it breaks on you. Now you got to do surgery on the print head. So this is behind that. It's gotten to that point to where it is a really handy appliance that you can go in there and design stuff right inside the slicer. We were saying before, the text tools to add labels for things is a lot easier than having to go inside of Fusion and it's like, oh no, where do I put this in the history?
Yeah.
Oh no, my whole freaking, it broke my parametric steps inside of Fusion. It definitely makes it a lot more easier to just mirror and then add your labels inside of Bamboo Studio. Then save it out with as an M3F file with all your things painted or oriented and whatnot.
Yep. And then with the Maker Lab portion of Maker World, which is Bamboo's website, they have all these generative tools for making really cool things. I don't know.
We just added like a chain link design one where you import a design, you could make inside of Tinkercad and it'll make it flexible. It'll add little chains to it.
Yeah, I actually trying to bring it up here. Can't quite. I have to let me run it because I'm in the middle of it. We're clicking too much. They just added this Flexi Toy Maker, which is I think the chain thing you're talking about.
Yes, Flexi Toy Maker.
Maybe we take a look at this next week or a week after.
To
see if we can make some fun Adafruit style toys or something. Maybe.
Yeah, right off the bat, I could see one of the Circuit Playground characters. Just import one of the vector files that Bruce has made inside there.
Yep, it could be fun. But there's a bunch of fun tools here. Make your own statues, litho panes, desk organizers, and just so many fun tools. And of course, it's ready to print designs that you can customize and make your own. Pretty cool. All right, just another thing here. Keychains.
Yeah, it is. It has made printing and designing exciting all over again.
Yeah, especially for kiddos too, for young makers.
Oh yeah, even this is actually pretty easy. Mike Jones saying that you got to take apart the AMS. It's literally just 2 screws, and I've not put those 2 screws back in specifically because when filament breaks in there, you just pop open the bottom portion of the AMS, and the tubes you just push on it, pull the PTF, the little tube that the filament goes through. You can take that out and then just push the filament out. That's way easier than having to disassemble a hot end or eat your hot end to try to push the filament out, or disassemble all the little gears to take that out of the Creality. So actually, this is easier to do than it has been in the past.
Yeah, I got one. No issues on my end with the AMS. Then again, I'm not doing much dual or multi-material. I just like having 4 colors ready to go, and I can I don't have to load them. It just loads it for me.
You can use them as like backups. So if one
backups,
spool runs out, it can load the other filament. Our neighbor got one too, and they had the same experience where they're it's all multicolor stuff is what they got it for. So they got the filament stuck inside the AMS, but like we were saying, it's super easy. Just take the
All right,
box.
that's good to know. If that ever happens to me, I'll
bro,
be
it's
rest assured that it's not hard to.
No, it is easy. It's way easier than it was before.
It's good.
Yeah, you just pop it out. I just leave those 2 screws out since I know it'll be back in there.
All right. Wait, another comment.
The bag slinger.
You just pull it out and insert your needs. You're comparing a jam, in which case they're both the same. Oh, okay. That's good to know.
Yeah. But again, the whole reason is that we're doing the multicolor. That's what the kids want, the different colors on it.
Yeah.
That's actually why we got it, because of the time lapses. We're looking so lame with just one color.
Yes. All right. We'll save Community Makes for next week since it's only 2 items and we're a little overtime now. But
right.
Yeah, I think we covered a bunch of stuff here. So I hope everyone had a good time hanging out with us, talking about CAD stuff, AI stuff, frightening AI stuff.
I know that's the theme for these, to make it.
How frightening can I generate a model? All right. Well, I want to let folks know that if you do want to support Adafruit, please use our coupon code if you want to get any electronics or things. 10% off. Coupon code this week is Mailbox, and that'll get you 10% off your order. Works on all physical goods. All right. Tonight we have back-to-back shows, starting off with Show and Tell. We invite you to come on and share your projects with the world. Tonight we have special guest host Liz Clark will be hosting tonight, I believe, at 7:30 p.m. Eastern Time. And then at 8 p.m. Eastern Time tonight is Ask an Engineer. New products. What else? INMPI, I think. Yes. Open source hardware news, tariff talk, maybe a tariff talk tonight. All that. And then, of course, more coupon codes on Ask an Engineer. That starts at 8 p.m. Eastern Time. Tomorrow is Thursday. You can tune in to John Park's workshop, where he live streams some new builds and things that he's working on. Happens at 4 p.m. Eastern Time. Friday, we got a deep dive with Tim, Foamy Guy. We'll be doing some CircuitPython development on Friday, 2 p.m. Pacific Time or 5 p.m. Eastern Time. From the desk of Lady Ada, we had one last Sunday. They normally happen on Sundays. Random hacker hours. And then on Monday, you can join in or listen in to the CircuitPython weekly meeting, where folks from the community and the devs, the core devs, come in and talk about CircuitPython, what's going on with the project, every Monday at 2 p.m. Eastern. All right. And then wrapping back around to our show happens every Wednesday at 11 a.m. Eastern Time. All right, folks, we'll see you tonight. If you come on, make sure you're in the Discord's chat group. And we'll see here one last time. There's a dancing dog.
I think that's real.
It's a real dancing dog.
That's a real dog dance.
Never forget that the real dog started it all. Good stuff. All right, thanks, everybody. We'll see you next week. But until then, remember to make
a great day.
Bye, everybody. See you tonight.